Okay guys, in this video we're going to be taking a look at our compounding interest model here, specifically um, the model that has us compounding things a certain number of times a year, and that is to say non-continuous growth models. And so we are not going to be using these models that we see here, these PERT models, but instead we're going to be looking at those really fun models that everybody loves to look at, which is an amount of something at a given time would be equal to the principal that we started with times 1 plus our rate over the number of times it compounds per year or per term to the power of number of times it compounds times the time. So this is the model that we're going to be looking at using here. And we certainly know that this is some exponential model where our dependent variable is an amount and our independent variable is our time here. So don't forget that we could certainly write this as y equals an initial amount times 1 plus r over n to the n times x, where just time is our independent variable and our amount at that time is our dependent variable here. And so we're just going to look at an example that says determine the amount of principal. So in other words, let's go solve for P here in our model. That must be invested at a rate R compounded monthly so that $600,000 will be available upon retirement. Well, that's a lot to kind of sink in here, but I suppose what I want to do is just start by identifying what are the things that we know. And so what we're looking for, at least what we're asked to go look for, is the principal. So with respect to our model, the only thing that we probably are not keen on is this idea of what P is. But it says find the amount of principal that must be invested at a rate R compounded monthly so that $600,000 will be available upon retirement. This $600,000 really here represents our amount. And so for letter A, let's go ahead and take a look at it. We know that our amount that we want to have available is $600,000. What we don't know is the principal. Now, in terms of the rate, we're told that this is a 7.2% rate, at least with respect to our given information. So 0.072 is our rate here, and our time is equal to 30 years. So this just only leaves this end part where we're told that it was compounded monthly. And so that'd be 12 times a year. So what I'd like to do is just go ahead and say, well, you know, if I'm already familiar with our model, and you're already giving me all these things and asking me to go solve for the principal, then really what we need to do is just go plug all these values in and work backwards to solve for, say in this case, the principal. So I'm going to do exactly that using our compounding interest model. And we're going to say that if I want 600,000 to be substituted in as the value of our amount, we say that that's the case if and only if we started with some amount P times 1 plus our rate, so that is 0.072, all over 12, because it was compounded monthly, to the power of 12 times, and in this case, we have 30 years, so 12 times 30. So all of this right here, all we're looking for is P, and what I recognize is that P is just really just being multiplied by all this stuff over here. And so what we could really do is we could divide both sides of this equation here by all of this quantity right here. And so I'm actually going to show my work here, even though I really don't like writing all these values on my little tablet here. It's not the easiest thing to do. 12 times 30. And what I do to one side, I got to do to the other side. So I'm going to divide by 1 plus 0.072 all over 12 to the 12 times 30. And so what would this mean? Well, it would mean that our principal is equal to 600,000 divided by 1 plus, all this in parentheses here, 0.072 over 12 to the 12 times 30. And this is just something that we can put into our calculators and evaluate for here. So let's go ahead and do that. Again, with modeling, you know, a lot of times I feel like it's the hardest part is crafting this on your calculator. So let's go ahead and be really careful how we do this here. And I suppose that what we're going to want to make sure we do is just use an abundance of parentheses. So already you notice that I have parentheses around my exponent here, 12 times 30. We'd have to do that first, and then raise all this to that power. And in a calculator, if I'm going to divide 600,000 by all of this, I might even go so far as to say, well, I'm going to throw in an extra set of parentheses here. I'm only using brackets for emphasis, but that's just like another set of parentheses. So we have 6 with 5 zeros, 1, 2, 3, 4, 5, divided by now our first parenthesis. We have yet another parenthesis here, and then we start in with our 1 plus 0.072 divided by 12. Now we're going to end that parenthesis, and we're going to say this was our entire denominator, which we were raising to the power of, in parentheses, 12 times 30. So we have to end our parenthesis on our exponent, and then we have one final end parenthesis, and that kind of just seals up everything in this denominator here. And so as we hit enter, what we determine is that we have about $12 cents, 69643. So about 69643 and 12 cents, and this is in dollars, okay? So one thing that I want to mention here is that this is just kind of a really neat thing to be able to say. Like, if you already knew what kind of a rate you were going to expect, and you knew how long you wanted to wait before you retired, and you knew how much you wanted to have available at that time, and you knew how many times a year it compounded, you could actually say, well, what is the amount of money that I'm going to have to start with here? And so if that's the case, you know, I would tell somebody over 30 years, I say, if you want to end up with $600,000, you're going to need to start with just a little bit under $70,000 here in order to make that happen. So what I want you to give a shot here is this letter B on your own, and you're going to get a different rate, and you're going to get it at a different time. So this would affect the amount of principal that you would have to start with. You're getting a better rate. So it would be easier for your money to become that $600,000 you need, but at the same time, you want to do it in 10 less years. And so I'm curious what you find out here. Are you going to have to start with more or less than what you started with in this 30-year period with only a 7.2% rate? Cheers.